Gels. Some lyophobic sol, example that of gelatin or agar-agar or gum aerobic etc., containing high concentration of dispersed solid on cooling change spontaneously into a semi-solid form that is jelly-like enclosing the entire liquid within it. The product thus obtained is known as gel and the process is known as gelation. Similarly, some lyophobic salts, example that of silicic acid or ferric hydroxide etc., which show some lyophilic character, also form gel under suitable condition when electrolytes are added into them. The colloidal solid constituting the liquid as a dispersed phase and solid as dispersion medium when present in a semi-solid state such that the entire liquid is enclosed within the solid is known as gel. This is believed that the gel consists of three-dimensional network formed by linking and cross-linkage of molecule contained of a solid dispersion medium within which the liquid of the dispersed phase is enclosed. Method of preparation of gel. Depending upon their nature, gel may be prepared by one of the following three methods. First method, by cooling the sol. When a lyophilic sol, such as that of gelatin or agar-agar, prepared in hot water and containing not too low concentration of the solid is cooled, it is transformed into a gel. This is because as the solid cool, the dispersed particles undergo hydration. As a result, they lose their stability and agglomerate together to form larger particles in the form of semi-rigid structure within which the entire liquid is entrapped. By double decomposition or metathesis, some hydrophobic gels such as that of salicylic acid and aluminum hydroxide, commonly known as silica gel or alumina gel, are prepared by this method. For the preparation of silica gel, hydrochloric acid is added to aqueous solution of sodium silicate. As a result of the double decomposition reaction, free cyclic acid is produced. It is highly gelatinous due to hydration and on allowing to stand rapidly sets towards solid gel. Similarly, for the preparation of alumina gel, some hydroxide solution and alumina chloride solution of suitable concentration are mixed. The hydrated aluminum hydroxide form on allowing to stand set into a solid gel. By changing of solvent. Some gel are formed by dissolving the substance in one solvent, then suddenly changing the solvent which is insoluble. For example, a gel of calcium acetate is obtained by this method. For this purpose, calcium acetate is dissolved in water so that the concentration is not too low and then alcohol is rapidly added to it. As a result, the salt is thrown out of the solution as a colloidal dispersion which on keeping set to a solid gel within which all the liquid is entrapped. Classification of gel. Gel are classified into elastic and non-elastic gel. The main point of difference between the two are followed. Elastic gel. These are those gel which possesses the property of elasticity. That is, they change to solid mass on dehydration, which can again be converted into gel by addition of water followed by heating and cooling. When placed in contact with water, they absorb water and smell. This property is called imbibition. Example include gelatin, agar-agar, starch. Non-elastic gel. These are those gel which do not possess the property of elasticity. They change into solid mass on dehydration which become liquid and cannot be converted into original form by heating with water. They do not show phenomena of imbibition. Most common example is silicic acid. Now there are some properties of gel. First is synthesis. When the gel, elastic or non-elastic, is allowed to stand for a long time, it shrinks and loses the entire liquid held by it. The shrinking of gel is known as synthesis. Second is thyrotropy. Some gel, like that of gelatin or mechanical shrinking, lose their semi-solid gel-like character and change into a liquid sol. This sol, on standing again, changes into gel. This reversible phenomenon involving gel-sol transformation is known as thyrotrophy. Imbition. When a gel is placed in a suitable liquid, it absorbs a large volume of liquid. The phenomena is called imbition or swelling. The effect of the presence of salt on swelling was studied by Hofmeister in 1891. He found that for the salt of the same action, same cation, example Na positive, the effect of certain anion was to inhibit the imbition, which that while that of certain anion was to favor the imbition. For example, in case of iodides, the swelling is so high that the gel disperses into salt even at room temperature. In other cases, the salt is formed by warming the swelling gel. The order of the temperature to follow the gel must be heated in the presence of various anions. Before it changes into salt, it is called Hofmeister series or lyotropic series. Greek. Lyotropic means change to liquid. The order is same as for salting out discussed earlier. That is, citrate 3 negative is greater than tetrate 2 negative, that is greater than SO4 2 negative, greater than PO4 3 negative, is greater than acetate, is greater than Cl negative, is greater than NO3 negative, is greater than Br negative, Br negative is greater than I, is greater than CNS. The anion from citrate to acetate inhibit the imbition, while from Cl negative to CNS negative favor the imbition. Thank you.